All right, we're recording, going on with continuing with our discussion of the moon, and now we're looking more specifically at moon phases. And you can see I have another one of those Nebraska Astronomy Department simulations up. And this one is our lunar phase simulator. And you can see up here I can change the moon phase. Right now I have it in the phase of full moon. And in the larger pane over here, I have the Earth and our observer on Earth. The sun is somewhere over here because here's the sunlight coming in. You can see right now, right, top view of Earth, we can see half the Earth is illuminated. We call that daytime. And half the Earth is in darkness. We call that nighttime. And you'll notice right now from my observer's position, it's right smack dab in the middle of daytime. So that would make it, if you turn on time, noon, right? And then as the Earth rotates, they would rotate for a while. And then at this point, the sun is setting. And if you look over here on what we call the horizon diagram, you can see that the sun is setting. And we would call that sunset. So we turn on the time again, sunset. They could go to midnight, sunrise as the Earth rotates. And you can see in the moon phase as a full moon, it's exactly on the opposite side of the Earth. And when you think about it, that makes sense. To be able to see the full lit side of the moon, it has to be exactly pointed at the sun, so it has to be exactly lined up with Earth. And you might be saying to yourself, if the moon is there, and the Earth is there, and the sun is over here somewhere, why isn't there a shadow? Well, you don't think three-dimensionally, right? If the Earth is here and the moon is here, above the Earth's shadow, it's not going to be an eclipse. We'll talk about that more when we get to eclipses. But for right now, this is a full moon configuration. As the moon phase changes, the Earth remains relatively stationary. Now again, it becomes more complex when we start talking about time of year. But for right now, just presume the Earth is relatively stationary, and our observer is just rotating. So sunrise, sunset, and you'll notice that, if I pause it here, the moon phase has already changed away from a full moon into what we call a gibbous moon. And if you look right on this very edge, you can see it kind of, the dark portion of the moon is creeping inward, lessening the amount of the lit portion we can see, about 97.3 illuminated, and you can see its position has changed pretty significantly in the moon's orbit of Earth. It's not a shadow on the moon. This is all about what we can see. So like right now, you can see my full face. If my position changes, well, now you can't see my full face. Does that mean I don't have a face? No, it just means you can't see it from where you are. This is very similar to how the moon works. And you can see as time progresses, the moon phase changes and we see less and less of the lit portion. Now, I'm going to let it go here a little bit, and then I'll pause it again. Does the actual amount of sunlight reaching the moon change? No. It receives half the moon is lit up at any one point in time, just like half the Earth is lit up at any one point in time. The moon phase is dependent on what we can see. So take a look right now. Here is our moon phase. We're still a gibbous. I'm going to flash that ahead to what we call a quarter moon. This will be a third quarter moon, right? So we can see half the lit portion, or a quarter of the entire moon. Half of a half. Quarter, right? I know, math, it's terrifying. And I want you to notice something. If I move my observer to directly under the moon is at its highest point. If I use my horizon diagram, the moon's at the highest point. What time is that? The sun is right there on the eastern horizon. We would call that sunset. Sunrise. Sun's on the eastern horizon. Sunrise. People get confused. They think, oh, the sun is out during the day and the moon is out during the night. But it's not. Depending on the moon phase, the moon might be out during the day. In fact, at certain times, the moon is only out during the day. It's all about relative position of the Earth, Moon, and Sun, and the moon phase changes with that position. Time changes with that as well. Time is based on the observer's location. So right now, our observer is right about at sunset. The moon is at its highest point in the sky. The moon would have been visible since around midnight. Watch the horizon diagram. As I move my guy backwards, right? There we go. The moon is just visible on the eastern horizon. That makes it moonrise, and that makes our time, boom, midnight, right? So time and moon phase are kind of independent of each. Well, I don't want to say independent of each other, but they aren't a direct relationship. The time of moonrise and moonset will change with the moon phase, whereas sunrise and sunset is set by the Earth-Sun position. Other moon phases, things you might be familiar with, if I go all the way to a new moon, you'll notice that the moon is lined up with the sun. So all of the lit portion is facing away from the sun. If I put my observer right under that, you'll notice that, oh hey, you don't see a moon on here, do you? It's because it's masked out by the sun. Again, you're not going to see the new moon because there's nothing to see. The lit portion is facing away from you. As we move a little bit off of that, we start getting into a crescent moon. So I'm going to go to a decent crescent so it's a little easier to see. And again, you start seeing just a little bit more of the lit portion. That doesn't mean they're still not half illuminated. What you end up doing is looking at the moon's orbit and the Earth's about. We'll save that for a second later. So hopefully this gives you an idea of how moon phases work. You can see as you go along, the moon phase becomes more and more illuminated. You see more and more of it until it gets to the first quarter, and then it'll continue going beyond that. Goes into a waxing gibbous, waxing of getting bigger phases, until it goes all the way back to a full moon, and the cycle repeats. This is a very neat little simulator, very helpful in seeing how the moon phase changes. So in your packet, you will find this diagram, which might help you physically understand what's going on. So on this first page here, it gives you Earth, the sun, and then several different moon phases, or moon positions, I guess. And it's asking us, well, if this is my moon phase, which I would call a crescent moon, what position is that? A, B, C, D, or E? And the way to figure it out is, remember, you see the half of the moon that is facing Earth. So if you take, say, position C, and I look at that, I'm going to see the half of the moon that's facing the Earth. So which half is that? Well, if I look from my Earth position, rotating this around, the left-hand portion will be lit up, the right-hand portion will be dark. So what that would look like, right, from Earth, position C, I'll go ahead and draw it down here, I am going to see the left-hand portion illuminated. The shading part, of course, is darkened. Does that match the question they're asking? No, it does not. So which one does? So we have a crescent moon, left side illuminated. Okay, if you take a look at this, there's just a little, sorry, off the page a little bit. There's a little bit of the lit portion you can see right on that side there, left-hand side. That's going to be D, right? The lit portion, left-hand side, just a little bit of it. If you take a look at like A or B, right, it's going to be kind of the opposite of that. We're going to have a little bit of the dark portion and mostly lit. So that'd be exactly opposite. That'd be what we call a gibbous moon. So A and B would be a gibbous moon, kind of a reverse crescent. And in B's case, it's going to be the darkened portion. I think I just drew that wrong. The darkened portion is going to be on the right-hand side. So we'd have a darker, and then the left-hand side would be illuminated. A would be the same idea but flipped because it's on the other side of full. That'd be a waxing gibbous, where this would be a waning gibbous. So hopefully that helps you understand where we get this idea of moon phase. It's all about what you can see from Earth. Kind of talked about that already. We're going to skip over that section. Again, just reminding you that, hey, half of the moon is going to be illuminated the entire time. Oh, this one's interesting. Again, we kind of talked about this as well. Right now, if we have an observer right here and the sun is directly overhead, that's going to be noon, right? Because here is the day-night line. This side will be dark, right? Nighttime. So if that's noon, what is this? Midnight. So that means this would be sunset. This would be sunrise. Looks a little different than the simulation because the sun is on the opposite side. So if the moon is here, could you see it at noon? It's a good question. Remember, you can see about a quarter turn ahead. So if I'm here at noon, I can see from here to here. From sunrise to sunset, you can see that. Does that include? No, it does not. The observer could not see that. So the question is, when could the observer see that? Well, at this point, that's when the moon is going to be on the horizon. And if you can see a quarter turn ahead, if I divide that into quarters, roughly, this is the point where the moon phase will become visible. So the question is, what time is that? Well, we're between noon and sunset, roughly halfway, so we'd say around 3 p.m. You'd be able to see the moon rising on the eastern horizon. Everything rises in the east on Earth because that's the way Earth is rotating. So just an idea of how moon phase and time work out for us. All right. So this page is going to be part of your assignment. And basically what I'm doing here, I'm going to do the first one here with you. So this is my example one. We're trying to figure out what would you see and then how would I name that moon phase. And there's a diagram similar to this in your book that might be useful to you as well. So remember, right, from Earth and the moon and the sun, we have to figure out which side's day and night, right? So right down the middle. Okay. Light side, dark side. So in this position, we're going to see none of the lit portion. It's going to be all dark. So I'm going to shade that entirely in. And this would be the new moon. Okay? Yeah. So, looking at other moon phases as we go on, let's do one more with you because that one's pretty easy. Okay? Let's go ahead, example 2. Again, sun, earth, moon. Figuring out which side is daylight and which side is darkness. Dark side. Dark side. And remember, we're going to see the half of the moon that is facing Earth. So I can see just a little bit right there. That's going to be on the right-hand side. So we're going to see a little bit of the right-hand side will be lit up. So that's going to be the lit portion. This is going to be the dark portion. and we would call that a crescent moon. So the question is it a waxing crescent or a waning crescent? And remember, if it's the right-hand side, that means it's going to be progressing, getting bigger, so this would be a waxing crescent. If it's getting smaller, be the left-hand side, it'd be a waning crescent. So hopefully this helps explain moon phases. Again, if we were in class, we'd spend a lot more time going through that packet and explaining this. Right now, just working on the basics. Hopes this helps. Again, if you have questions, get a hold of me, let me know. Have a great day.